Hello grade 10s, welcome back to another exciting video. So in today's video we'll be doing physical sciences. This was written in March 2024 from the Limpopo province. So we'll be doing this question paper together today. I will not be doing the multiple choice. We'll just go straight into long questions because this question paper is long, guys, very long. I'll probably treat multiple choices in separate videos in future, but for now I will not be touching multiple choice questions, and I'll only be going straight to straight questions because this is very long. We have like 8 questions, so yeah, I just want to get through them as fast as possible so that this video is not too long. Please don't forget to like, comment, and subscribe to the channel. It's free, guys. Free old clock. You don't have to pay a dime. So please subscribe if you like these videos and like them. If you like these videos, I recreate them more. Okay, so if you like and share your thoughts in the comment section, comment whatever that you can comment you've enjoyed, what can be improved, or what you would like to see. Please comment. Like this video. You probably get this type of videos every week because you liking, you're engaging. So I know what you guys like. You just watching is not enough satisfaction. I don't know, you just watching because, and I don't get to know for how much of the video did you watch. So if you like the video, if you comment, if you subscribe as well, I get to see that okay, people like this video and I've gotten more subscribe from this video, so I will create this type of videos more. Okay, so please subscribe so that I can make more of past question papers because you guys enjoy them and they are helpful. Now let's get into the video without wasting any more of your time. So here we have the question. This question paper consists of 10 and 1 data sheet. Instructions and information is on question 2. Write your name and say name on the answer book. It is an instruction. This question paper consists of 8 questions. Answer all the questions in the answer book. Start each question on a new page in the answer book. Number the answers correctly according to the number system used in this question paper. So you cannot write question 2 and then number it as question 1 and expect to be marked. Okay. Leave one line between sub questions, e.g. between 2.1 and 2.2 you should skip a line. And then you may use a non-programmable calculator. You may use appropriate mathematical instruments. You are advised to use the data sheets. Those are showing formulas. Show all formula and substitutions in all calculations. And then round off your final numerical answer to a minimum of 2 decimal places. So if you're working with decimals, minimum of 2 decimal places. It's a very important instructions. Show all formulas and substitutions. So guys, if you're substituting something into a formula, a number into a formula, you do brackets. That's how you show that you have substituted. So give brief motivations, discussions, etc. were required. Write neatly and legibly. So I'm just going to pass the multiple choice questions and go straight to the long questions. So here we have question 2. Transverse waves with a wavelength of 0.5 meters travel along a string at 0.25 meters per second. The amplitude of the wave is 0.20 meters. So define a transverse wave. Make sure, guys, you have examination guideline. Go on Google. When you get to Google, type physical science grade 10 examination guideline, and then go on the search bar, and then when you search, it will appear as a PDF. Download it to your phone, so you only use definitions that are in your examination guideline. Okay, it's very important that you follow your examination guideline. Thank you. Now we're going to answer this question. What is a transverse wave? Meaning, define a transverse wave is the same as what is a transverse wave. A transverse wave, so this is the meaning of a transverse wave. A transverse wave is a wave in which the particles of the medium vibrate perpendicular to the direction of motion of the wave. So that is the answer. Draw a labeled diagram showing two wavelengths. Wavelength, we need two wavelengths of the wave to illustrate your answer. Label the directions of disturbance, the propagation, the amplitude, and the wavelength. So here we are asked to draw a labeled diagram showing two wavelengths of a wave. So we are asked to draw two waves. I'm going to write, you need to draw a line there, and then let's change the color. The wave will start here. This is one wave, this is the second wave that ends here. So I will say around here, maybe we'll separate these waves. This part is the another wave, this part is the second wave. Okay, so we have our wave like that, and then here, this length here is what we call amplitude. That will be our amplitude, and then this is the wave length. That will be our wavelength, and then we will say this will be direction of propagation. Okay, so that will be direction of propagation, and then this one here will be direction of disturbance. Yes, so that is our drawing there. So I'll show it in the memo to show it a bit cleaner than the one that I have written here. Yeah, so we are asked to show two wavelengths. I've showed you the two wavelengths. Oh, I forgot to write the meters. That is 0.4. You have to include it even if it's not up to scale. And then the amplitude, write it that it's 0.2 meters. And then write direction of propagation and then direction of disturbance. So this is what you are asked to draw. I show you different wavelengths, so you saw them. And 2.3 says calculate the frequency of the waves. And then what you do when you calculate, you come to your formula sheet. This is the information sheet. There you look for waves, sound and light. So these are the only formulas you have for waves, sound and light. So these are the only ones that you're going to use, guys. Okay, these are the only formulas you will use. And so because we're asked to calculate frequency, we will use the first one, V equals to F, and that line T there. So that's what we'll use to calculate frequency. So you only stick to the ones that you have, okay? You do not make up your own formula that you know in class. Stick to the ones that are shown in the formula sheet. Look for that thing under that section, look for it. So there we found frequency. I hope you learned this in class. So let's calculate frequency. Remember that we have a wavelength of 0.4, which is the V on that formula, and then they travel along a string at 0.5 meters per second. So we're going to use that wavelength, and the 0.25 travel along a string will be that T that is lying down. All right, so here we say V equals to, so V is the wavelength. So we have the wavelength and that T, we do not have the frequency. So we'll say 0.25 to replace the V. Okay, and then we have F, and then we have 0.45. When you substitute, you show by brackets. So we have something like this. We want to have F by itself because we're trying to calculate F. So we'll divide both sides by 0.45 to get rid of it. 0.45, and then when you have done divide it, we can cancel it. Then we will have 0.25 over 0.45 equals to F. You put this in your calculator. Frequency is measured in hertz, okay? So you will have that your frequency is equals to 0.56 hertz. When you put this, you say 0.25 divided by 0.45. That will give you 0.65 hertz, okay? It will give you 0.55555 and 6. So you round off to 2 decimal place. 5 it takes you up to 6. Yeah, so this is the full answer. So it starts here, 2.3, and then it ends here, and then we will have 2.4 here. So 2.4, we are asked to calculate the period of the waves. So let's calculate the period of the waves. Remember that period is time. So when you're talking about period, we're talking about time. So time, as you learned in class, is 1 over F, 1 over frequency. So let's look if we have that formula. Yes, time equals to 1 over F. So time and period is the same thing. So yes, I will be writing here. We will use time equals to 1 over frequency, and we calculated the time. We just calculated the time, guys. Here, not the time, we just calculated the frequency here. So frequency is 0.56, and then time is 1 over frequency. So we are going to write time is over 1 over 0.56 hertz. You put this into your calculator, then you'll get that time is equals to 1.79 seconds. So time should be in seconds, okay? So it's 1.79 seconds. That is time. So when the frequency of the wave is doubled, how are the following quantities affected? Right, only decrease, no change, or increase. So if the frequency is doubled, the speed of the wave will increase. Okay, so if frequency is more, the speed will increase. But if the amplitude, if frequency is doubled, the amplitude will have no change. So amplitude, it doesn't affect the length of the wave. The amplitude will not be affected if frequency is doubled. Okay, so there will be no change, but speed of the waves will definitely increase. So 2.5.1 is increase, and then 2.5.2 is no change. We are done with question 2. Let's go to question 3. So question 3.1 says define the term longitudinal wave. So longitudinal wave is waves in which the particles of the medium vibrate parallel to the direction of the propagation of the wave. So that is longitudinal wave. Then we will move to 3.2.1. Let's say 3.2, then 3.2.1. So, two learners used a slinky string and produced a wave pattern as shown in the sketch. Okay, slinky movement, wave propagation there, OXPY, and then there is 550 millimeters. So point X and Y represent regions where the coils are spread apart. X and Y, the strings are spread apart, thus maximizing the distance between coils. What is the name given to such point? So where the coils are spread apart like that, we call them rarefactions. Okay, where they are spread apart is rarefactions. I'm just writing here so that you can see it. I hope you're familiar with it and you see it in class. You've talked about it with your teacher. And then point OP and Q. OP and Q represent regions where the coils are pressed together in a small amount of space. What is the name? Is compressions. Okay, so where they are coiled together is compressions, and then where they are spaces in between are rarefactions. So, or rarefactions, yes, whatever you use, your teacher uses, use that one. So, and then 3.2.3 says determine the wavelength of the waves in meters by making use of the sketch. So we need to determine the wavelength of the waves in meters. Here we are given 550 millimeter, and then what else are we given? Yeah, so there we have to write meters. So we convert millimeters to meters. When you convert millimeters to meters, you're going to take your meters and then you divide them by 1000. You're going to take your millimeters, divide them by 1000. That will give you your meters. So we take 150, then we divide that by 1000, and that will give us 0.55, and then 3.2 point, oh, this is 2.2.3, then this is 4. we are asked to calculate the period of the wave. If the velocity is 9, so we're still going to use that formula, v equals to f. We also calculate the period. So for us to calculate the period, we don't have the time. So for us to get the time, we must get the frequency. Okay, that's how this thing works. We don't have the time, but we can calculate the frequency. All right, so we have the wavelength and we have the period, the velocity. So we can use those two to calculate the frequency, and then we say 1 over frequency is equals to the time. All right, so v equals to f, v equals to 9 equals to 0.55. Then we divide by 0.55. Remember 0.55, what we did the last time. So f will equals to 9 over 0.55, and that will give us 16.36. So time equals to 1 over f. So time equals to 1 over 16.36. Time equals to 1.16.36 in your calculator. Yes, 0.06. Yes, that's how we do this question. Question 4 says, we plucked a guitar string emits. When plucked, a guitar string emits a sound with a frequency of 256 hertz. The wavelength of the sound is 1.33 meters. When the tension of the string is tightened, the guitar string vibrates with a frequency of 300 hertz. Calculate the speed of sound in air. So here, question number 4, we're going to calculate the speed of sound in air. So the speed of sound, let's see what we have. When plugged, a guitar string emits a sound with a frequency. We are given a frequency, and then we're given the wavelength, which is 1.33. So we are looking at when the tension of the string, the speed is the v. Okay, so speed is velocity. Keep that in mind. Always know speed, velocity. 4.1, we still use, we see you're going to get a lot of wave question. F equals to, so we're looking for the v equals to 256 multiplied by 1.33. Sorry, 1.33, and then v equals to 340.48 meters per second. So this is how you write velocity. And then 4.1.2 says, when the tension of the string is tightened, focus, taking long to focus. All right, when the tension of the string is tightened, when the tension of the string is tight, when the tension of the string is tightened, how are the following properties of the sound waves affected? Only write increase, decrease, or remain the same. So if the tensions of the string is tightened, the pitch of the sound will increase. So 4.1.2.1 is increase, and then 4.1.2.2 is the speed will remain unchanged. So 4.1.2.2 is unchanged, and then 4.1.2.3 is decreased. Okay, the wavelength of the sound will decrease when the tension of the string is tightened. Now 4.2 says distinguish between pure note and a noise. So 4.2, you distinguish between a pure note and a noise. So here it is, and those ones that I also talked about. A pure note has uniform frequency and wavelength, while a noise have irregular frequencies, amplitudes, and wavelength. So you have to know that. And then 4.3 says an earthquake produces waves of frequency 23,100 hertz. Most often, fewer animals die during an earthquake than people. What name is given to sounds of frequencies in this range? They are ultrasounds. Okay, so that is an ultrasound. You can go and Google what an ultrasound is, and yeah, just to learn more about it. And then 4.3.2, explain why fewer animals usually die during an earthquake than people. I'm going to show you the memo. That is 4.2.3. And then 4.3.3 says explain how human beings can avoid dying in large numbers. You are science students, so it's very important that you learn about ultrasounds and stuff. If you don't have a textbook, go on Google, say grade 10 physical science textbook PDF, and then things will pop up. Then download, even if it's a study guide. On Via Africa, there are study guides, free ones, if they do not give you a textbook in school, so that you'll be able to familiarize yourselves with theories that go with physical sciences. So it's very important that you get yourself a textbook, that you have background information. So animals can hear sounds of this frequency and move to a place that is not affected by the earthquake. So whenever an earthquake is happening, so how can they protect themselves from dying? Is moving to a place that is not affected by the earthquake. So 4.3 says human beings may study the movement of animals and react to the sudden change of place by the animals as a warning signs. So when animals see danger, they will move to a place where they will not be protected. So human beings can see that sign from human beings as showing that there is danger coming. So we will use that formula that has E equals to HF, E equals to HCT. Yeah, so we'll say C equals to frequency times wavelength. So we are looking for the C. So C, that is speed of light in a vacuum, that is the C. So we're going to use that one. If we are not given speed, we just write to calculate frequency, and we are given wavelength. So you see that, use that C in this constants, physics constants. So 3.0 times 10 to the power of 8 meters per second, that's the C. That will be C equals to, so you use this formula whenever you're not given the velocity or the speed. That is equals to 1 times 10 to the power of 8 hertz. So this is your answer. So this is beginning of question 5. It's raining outside. This is question 5. And here we have our calculations. Let's go to question 6. Guys, it's raining and I'm afraid I'm not gonna be able to finish this question paper, but as soon as the rain comes down, I will continue with this question. So you will find this question on Wednesday, because I'll be posting this one will be live on Tuesday today, and so tomorrow come back at the same time, 1 o'clock, South African time, 1 o'clock. I will post. I will do question 6, 7, and 8 on that tomorrow. So that will be our part 2. I will name this as part 1. Then we'll do part 2 tomorrow. Thank you very much for watching.